Have you ever wondered how hydrogen fuel engines are made? Picture a system that transforms hydrogen gas and oxygen from the air into electricity, with the only byproduct being water vapor. This is no science fiction. Hydrogen fuel engines, also known as hydrogen fuel cells, are real and they're contributing to a more sustainable future. These engines are complex systems constructed through precision engineering and meticulous assembly. They are made up of several layers, including electrodes, an electrolyte, and separators. Each component plays a vital role in the conversion of hydrogen gas into electricity. But the manufacturing process doesn't stop there. Once assembled, these engines undergo rigorous testing to ensure they meet efficiency, performance, and safety standards. And when they pass, they're ready for deployment, powering everything from vehicles to backup power systems for buildings. Intrigued? Eager to learn more? Let's dive into the fascinating process of making hydrogen fuel engines. The process begins with the creation of electrodes. Electrodes are crucial components of hydrogen fuel cells, serving as conductors for the electricity generated. They come in pairs, an anode and a cathode. These are typically crafted from porous materials, allowing gases to seep through and participate in the essential chemical reactions within the cell. A catalyst, often platinum, is coated onto the electrodes. This catalyst accelerates the chemical reactions, splitting hydrogen molecules at the anode and encouraging oxygen molecules to react at the cathode. In essence, the electrodes are the stage for the performance. The porous material is the backdrop, allowing the actors, the hydrogen and oxygen gases, to enter, and the catalyst is the director, speeding up the action. It's a meticulous process, requiring precision and care. But the result, an efficient, effective means to generate electricity. With the electrodes ready, we move on to the next step. The next step is the production of the electrolyte. Now you might be wondering, what's an electrolyte? Well, it's the secret sauce that allows ions to move between the electrodes within the fuel cell. It's like a highway for ions, enabling them to zip back and forth, thereby facilitating the conversion of hydrogen and oxygen into electricity. Different types of fuel cells use different sorts of electrolytes. For instance, proton exchange membrane fuel cells, often referred to as PEM, use a solid polymer as the electrolyte. Alkaline fuel cells use a solution of potassium hydroxide, whereas phosphoric acid fuel cells, as you might have guessed, use phosphoric acid. There are also molten carbonate fuel cells and solid oxide fuel cells, each with their unique electrolyte composition. Each kind of electrolyte has its pros and cons, and the choice largely depends on the specific use case. Now that we have our electrolyte, we can start assembling our fuel cell. Assembly is a meticulous process that requires precision and care. Imagine a puzzle with each piece meticulously crafted to fit perfectly into its designated spot. That's what the assembly of a hydrogen fuel cell engine is like. The electrodes, electrolyte, and separators, each fabricated with precision, are now ready to be assembled into a stack. Picture a sandwich, if you will. The electrodes are the bread, the electrolyte is the filling, and the separators are like the toothpicks holding everything together. Each layer is carefully aligned to ensure the proper functioning of the fuel cell. Now, imagine if this sandwich had a gas leak. Not a pleasant thought, right? That's where the gaskets and seals come in. Just like the crust on our sandwich, they are used to prevent gas leaks, ensuring that the hydrogen and oxygen stay where they're supposed to be. Once the individual stacks are assembled, it's time to integrate them into a larger system, much like grouping several puzzle pieces together to form a bigger picture. This integration process is not a one-size-fits-all operation. Depending on the application, it may involve connecting multiple stacks in parallel or series to achieve the desired power output. Think of it like a choir. Each singer, or in our case, each fuel cell stack, has its own unique voice. But when they come together, they create a harmony that's more powerful than any individual voice. Whether it's for a small portable generator or a large stationary power plant, the fuel cell stacks are integrated into a system that's just right for the job. With our fuel cell assembled, we're ready for the next phase. But remember, like any masterpiece, the creation of a hydrogen fuel cell engine is a process that requires not only skill and precision, but also patience and dedication. Each step, each component, each minute detail is a testament to the marvels of engineering and a step towards a cleaner, more sustainable future. The balance of plant, or BOP, is a crucial part of any hydrogen fuel cell system. Let's delve into what makes up the BOP. First off, we have the hydrogen storage tanks. These tanks hold hydrogen that is used as fuel in the cell. They're designed to safely contain the pressurized hydrogen gas without any leakage. The design and construction of these tanks are critical because hydrogen is both highly flammable and can cause embrittlement of certain materials. Next, we have the oxygen supply systems. These systems draw in oxygen from the surrounding air. The oxygen then combines with the hydrogen in the fuel cell to produce electricity. The oxygen supply system is usually designed to filter out dust and other impurities from the air that could damage the fuel cell. Then comes the cooling systems. Hydrogen fuel cells generate heat as a byproduct of their operation. This heat must be dissipated to prevent damage to the cell and maintain its efficiency. The cooling system is typically a series of pipes filled with a coolant, much like the radiator in your car. Humidifiers are another important component of the BOP. They ensure that the air entering the fuel cell has the right level of humidity. This is important because the proton exchange membrane in the cell, which allows ions to move between the electrodes, needs a certain level of moisture to function effectively. Last but not least, we have the controls. These are the brains of the operation. They monitor the system's performance and adjust the inflow of hydrogen and oxygen, the cooling system, and other parameters to keep the fuel cell operating optimally. The controls can also detect faults and shut down the system if necessary to prevent damage or hazardous situations. So, as you can see, the balance of plant is a collection of systems that work together to support the main action of the fuel cell, converting hydrogen and oxygen into electricity. Each component plays a vital role in ensuring the safe, efficient, and reliable operation of the fuel cell. With the BOP in place, we're ready to test our fuel cell engine. Testing and quality control are vital steps in the manufacturing process. After all, we are dealing with a sophisticated energy conversion system, and we need to make sure it's up to par. Each hydrogen fuel cell system undergoes rigorous testing to ensure it meets performance, efficiency, and safety standards. Imagine the system being put through its paces, operating under simulated conditions that mimic real-world demands. These tests are designed to push the fuel cell to its limits, assessing its responses, resilience, and reliability. Next comes the meticulous quality control checks on individual components. Each electrode, each electrolyte, each separator, every gasket and seal, every single component is examined, ensuring it meets our stringent standards. These checks are not just about ensuring functionality, but also about maintaining the highest level of safety. After all, we're dealing with hydrogen gas and oxygen, the substances that power the system. Once our fuel cell engine passes these tests, it's ready to be deployed. Deployment is the final stage in the manufacturing process. Once a hydrogen fuel cell system has passed all testing and quality control checks, it's ready to serve its purpose. But what exactly are these purposes? Well, the applications of hydrogen fuel cell engines are as diverse as they are impressive. Imagine cars, buses, trains, and even airplanes all powered by these engines. Picture them emitting nothing but water vapor, contributing to a cleaner and more sustainable environment. Imagine remote locations, far off grid, still having access to reliable and clean power. And think of buildings equipped with backup power systems, ready to keep the lights on when the grid fails. All these scenarios are possible thanks to hydrogen fuel cell engines. But the journey doesn't end with deployment. Like any complex system, hydrogen fuel cell engines need ongoing maintenance and support. This is vital to ensure their optimal performance and longevity. Routine inspections are carried out to check the condition of the fuel cells and other components. Consumable parts are replaced as needed, and any issues that arise during operation are swiftly addressed. This ongoing care is crucial to keeping hydrogen fuel cell engines running smoothly and efficiently. This maintenance and support, however, isn't a one-size-fits-all solution. The needs of a hydrogen fuel cell engine in a car will differ from those in a stationary power system, but regardless of the application, the goal remains the same: to maximize the engine's performance, lifespan, and overall contribution to our sustainable energy future. And that's how a hydrogen fuel engine is made. From electrode fabrication to deployment, each step is vital to creating an efficient and reliable power system. It's a testament to the power of precision engineering, careful assembly, and rigorous testing, and it's a promising step towards a cleaner, more sustainable energy future.